The trouble in Wilmington, North Carolina began with houses that looked perfectly fine. That's the part worth sitting with for a second. In August of 1995, inspectors in New Hanover County started running moisture readings on homes clad in synthetic stucco, the sprayed-on exterior finish that had swept through coastal neighborhoods because it looked like old-world plaster at a fraction of the price. J. Alan Golden, then assistant director of the county's building inspections office, tested 31 of those houses. All but 2 came back wet inside the wall. Several were already rotting, so the testing widened. A larger round covering 300 synthetic stucco houses across several North Carolina cities turned up moisture problems in 98% of them. An architect named Henry Johnston supervised testing on another 209 homes in Wilmington and found elevated moisture in 90%. Both men said plainly that these were not scientific surveys, just what they kept finding. The numbers still landed like a dropped anvil. Here's the detail that matters. A healthy exterior wall reads around 10% moisture content or less. Readings in the 20s are a warning. Above 30%, wood rots. Those houses were full of readings in the danger band, and the way Golden described them to a reporter at the time was that to the untrained eye, they looked fine. Not entirely fine. There were marks, faint, dark smudges under window corners, streaks where a roof met a wall, the kind of blemish a person washes, caulks, paints over, and forgets about because that is what you do with a smudge. The first repair estimates ran past $25,000 per house, and then, because reality is rarely tidy, a later round of inspections organized by the industry's own trade association concluded that roughly half of the affected homes needed under $3,000 of work. Both figures are real, and the gap between them is the whole point. 2 houses wearing the same small mark could be $400 apart or $40,000 apart, and the mark itself told nobody which one they were standing in front of. That's because a stain is not damage. A stain is a record of where water stopped moving. Water goes somewhere, slows down, sits, evaporates, and leaves behind whatever it was carrying. Dissolved minerals, wood tannins, dust, rust, drywall sizing. The mark is the evaporation line. It's the place the water gave up, which is almost never the place the water got in, and it says nothing at all about how much came through or whether more is on the way. 2 questions decide the cost, and neither of them is how big the mark is. First, is water still arriving? Second, can the assembly behind it dry faster than it gets wet? Everything else is detail. A stain has 4 readable properties, and most people only ever use one of them. The boundary is the most informative. When water wets a porous surface and then evaporates, whatever it carried gets concentrated at the outer edge. It's the same effect that leaves a dark ring where a coffee cup sat, and the same principle behind paper chromatography, where a single drop of ink separates into bands as the solvent creeps outward. On a ceiling, each separate wetting event lays down its own edge. Concentric rings mean the ceiling has gone wet and dry repeatedly, which means multiple events, which means whatever caused them is still in operation. One soft blotch with no defined edge usually means a single event or slow continuous wetting that never got a chance to dry between rounds. Color narrows the source. Yellow-brown almost always means the water traveled through wood or through the paper facing of drywall and picked up tannins. Gray or sooty edges suggest it carried particulate out of an attic or a wall cavity. A chalky white bloom means mineral salt, which means masonry. Small orange dots mean iron, which means fasteners. Texture separates past from present better than color does. Dried staining is flat and hard and feels like the surface around it. Actively wet drywall feels cool and slightly giving under a fingertip. Paint that has bubbled or lost its grip is reporting that the substrate underneath was wet enough to break the bond, which is a fairly recent event. And then the property that settles the argument change over time. Draw a light pencil line around the mark. Write the date next to it. Then watch it against 2 things: weather and normal use of whatever fixtures sit above or behind it. If the boundary moves past the pencil, water is still arriving. If it doesn't budge through a heavy rain and a week of showers, the event is historic. A pinless moisture meter shortens all this considerably, though it lies enthusiastically around metal. A reading that pins the needle is usually a stud, a pipe, or a corner bead rather than a flood. Now the marks. They're arranged deliberately, starting with the ones whose source sits directly overhead and ending with the ones whose source is underneath the floor, because that migration away from the obvious is the whole argument. Start with the classic, a ring on a ceiling directly below an upstairs bathroom. Most of the time, this is the dull answer. The joint where a tub or shower wall meets the deck, letting a little past on each use. A drain connection weeping under the trap. A toilet's wax seal gone flat, so a small amount escapes with every flush and follows the outside of the drain pipe down into the floor structure. Plywood subfloors are patient. They can absorb a remarkable amount of wastewater over months before the first mark appears below. The version that costs money is a pressurized supply line or a failed shower pan liner. A drain leak only leaks while the fixture runs, maybe 2 minutes a day. A supply line is under pressure around the clock, so it delivers on a completely different scale while producing the same modest ring. A failed pan liner soaks the mortar bed and the framing under the entire shower footprint before anything shows up downstairs. The spread in cost is brutal. A wax ring is a few dollars in parts. Shower pan replacement generally runs somewhere between $530 and $4,600, with around $1,600 a common midpoint, and that's before touching the ceiling below it. Water-damaged ceiling repair commonly runs $45 to $55 per square foot, with typical single-area repairs landing between $400 and $1,500. Settling it is mostly free. Shut off every fixture in the house, read the water meter, wait an hour, read it again. Movement with everything off points to a pressurized line. Stop using the shower for 2 or 3 days and watch the pencil line. Fill the tub, then release the whole thing at once and watch the ceiling below. If wetness follows the dump, it's the waistline or the trap. The pan itself gets confirmed with a hydrostatic test. Plug the drain, fill the pan, hold it a day, watch the water level. That's the same flood test many plumbing codes require at installation, held anywhere from 24 to 72 hours depending on the jurisdiction. 2 safety branches belong right here, and both need stating completely rather than halfway. If the mark touches or surrounds a light fixture, a ceiling fan, or a smoke alarm, or if water is coming out of a fixture, don't touch the fixture, the bulb, or the wall switch. Go to the electrical panel and shut off the breaker for that circuit. If you can't identify which breaker serves it, shut off the main. If the panel itself is wet, or you would have to stand in water to reach it, stay away from it and call an electrician or the utility. Leave that circuit dead until an electrician has inspected the fixture and the wiring. Second, if the ceiling is sagging, bulging, or feels soft when touched near the edge of the stain, get out of the room and keep people and pets out of it. Saturated drywall carries a great deal of weight and it lets go all at once. Do not puncture it to drain it. If the source is plumbing and you can reach a shutoff valve without walking underneath the bulge, close it. If you can't, leave it alone and call a plumber or a restoration crew. A flat, small, slightly damp patch with no sag is the case where drying and monitoring is reasonable. A drooping one never is. Move sideways to the second mark. A slowly growing stain on a wall near a tub or shower surround, sometimes with a matching one downstairs. Grout isn't waterproof, and the caulk line where the wall meets the tub is a wear part with a service life measured in years. Water crosses that joint, gets into the wall, and takes months to show anything. Less often, the trouble sits behind the tile entirely, a weeping connection at the mixing valve body. Isolating it takes patience rather than tools. Dry everything, then run the shower with the spray deliberately aimed away from the walls, water going down the drain only. Then run it with the spray hitting the wall. Then plug the drain and fill the base without running the spray at all. Each of those wets a different path. If the mark advances while the valve is running but no water is touching the tile, the problem is behind the wall, and that means opening tile. Third, a stain around a plumbing penetration or an ice maker line. Small diameter tubing causes damage out of all proportion to its size, and the refrigerator line is the poster child. The thin plastic tubing that ships in the box gets kinked behind the appliance, hardens with temperature cycling, and weeps at a rate too small to ever puddle. Nobody moves a refrigerator. A cabinet toe kick hides the rest. The water goes under the flooring into the subfloor and travels along the plywood, and by the time anything is visible, the visible thing may be a bulge in the ceiling of the room below. There's a second version worth knowing: the penetration itself. Where a pipe passes through a plate or a subfloor without being sealed, water tracks along the pipe and lands several feet from where it started. The sting on this one isn't only the repair. Standard homeowners' policies exclude constant or repeated seepage or leakage over a period of weeks, months, or years, and many carriers mark that boundary at 14 days. The sudden burst tends to get paid. The patient drip that finally announces itself after 4 months tends not to. Which is a strange incentive structure, honestly. The failure that damages a house most thoroughly is the one least likely to be covered. Prevention here is almost insultingly cheap. Twice a year, pull the refrigerator out, check the connection points for mineral crust, and check the tubing for kinks. Swapping plastic supply tubing for braided stainless is a small job that removes an entire failure mode. Fourth, small rust-colored dots on a ceiling, sometimes with a slight bump under the paint. Most of the time, these aren't a leak. Drywall fasteners aren't galvanized, and they conduct heat straight through the assembly, so their heads sit cooler than the board around them. Humidity condenses on the cool spot, the steel rusts, the rust bleeds through the paint. The giveaway is geometry. Regular spacing and straight lines that follow the framing is a fastener pattern, and water paths don't come out in a grid. The version that matters is when those dots are the low point of an assembly that's genuinely wet. An attic with a ventilation or air sealing problem where moist indoor air condenses on the underside of the roof deck all winter and drips down. Sanding and a stain-blocking primer fixes the first case. It buries the second. Settle it by season. Fastener corrosion tends to appear or worsen in winter and then stay put. If the dots are joined by broader damp areas or the attic shows frost on nail points and darkened sheathing on cold mornings, the ceiling is reporting on the attic's air, and the shingles have nothing to do with it. Fifth, and this is where the source stops sitting above the mark at all, a stain that starts at the edge of a ceiling register and creeps outward, or a line running along a duct. In humid weather, this is usually condensation. Cold supply air chills the metal duct running through a hot attic. Humid attic air touching that cold metal drops below its dew point. Water forms on the outside of the duct and drips onto the ceiling. It happens wherever duct insulation is thin, torn, or gapped, and it peaks in late summer when the air conditioner runs nearly continuously and attic humidity is at its worst. Burying ducts in loose insulation can make it worse because the surface temperature under all that insulation drops further still. There's a competing explanation. A roof leak that used the register boot as a convenient low point. The calendar sorts them. Condensation tracks with humidity and equipment runtime and vanishes in cool, dry weather. Rain-driven staining tracks with rain and doesn't care what the thermostat is doing. Log both for a month and the mark tells on itself. Sixth, staining below a window or peeling paint on the interior stool or a soft lower corner of trim. Ordinary cause, failed sealant, $20 to $50 in materials and an afternoon. The expensive cause is the detail behind the wall, a missing sill pan or flashing that wasn't lapped so each layer sheds onto the one below it. Get that wrong and water crossing the outer surface has nothing to carry it back out, so it lands on framing and stays there. Wilmington again. In one of those studies, 38% of windows lacked proper caulking, and the lower corners were where it collected. Reflashing a window runs roughly $300 to $700 each. Rot repair spans a couple hundred to several thousand, with a single localized repair often landing around $500 to $1,100. Settle it with a garden hose, bottom up, wet only the area below the sill for 5 minutes and check inside. Then the jambs, then the head, then the wall above. Working upward isolates each stage, and the first stage that produces water inside names the failure. That's a crude version of what building consultants do with a calibrated spray rack under the standard known as ASTM E1105, which sprays water at a controlled rate while a chamber pushes air against the assembly to simulate wind. Seventh, a stain near a chimney chase or where a roof meets a wall. Flashing at these transitions is the most common recurring roof-related leak there is, and the reason it defeats people is that the mark is downhill from the entry, never below it. Water that gets under a covering follows the underside of the deck, runs along a rafter, soaks into insulation, and stops wherever something interrupts it. Stains 10 to 15 feet away from the actual entry point are completely routine. The most damaging version is a missing kickout flashing, the small piece at the bottom of a roof-to-wall junction whose entire job is to throw water out onto the siding instead of behind it. Without it, water gets channeled straight into the wall cavity, where nothing stains anything for a very long time. The move is to follow the framing uphill from the mark, since inspecting the roof directly overhead usually turns up nothing. An attic inspection during or immediately after rain beats any amount of speculation because the wet trail on sheathing and rafters points back toward the entry. Cathedral ceilings have no attic and no access, which puts that one squarely in professional territory. Eighth, a mark that shows up 2 or 3 times a year and behaves itself the rest of the time. That's usually wind-driven rain on one elevation. Ordinary rain falls on horizontal surfaces. Wind-driven rain lands on vertical ones and gets pushed into any gap facing the weather, which is how a wall can stay watertight for months and then leak twice in one spring. Restoration professionals take this seriously enough that the industry standard lists wind-driven rain from storms among its examples of the most contaminated water category. The language says it can be, not that it always is, and the distinction depends on what the water passed through on the way in. The diagnostic is a notebook. Every time the mark changes, write down the date, whether it rained, and which way the wind was blowing. 3 or 4 entries in the elevation names itself, which turns a mystery into a bounded inspection of one wall. Ninth, a stain on drywall behind the baseboard or a baseboard swelling and darkening on a wall that faces outdoors. The usual cause is the ground. Residential code asks that finished grade fall at least 6 inches within the first 10 feet away from the foundation and that hard surfaces within 10 feet slope at least 2% away. Siding wants clearance too, commonly 6 inches above soil and 2 inches above a deck or patio. Those margins get eaten quietly. Mulch piled a little higher each spring, a patio poured level with the siding, a garden bed raised. Once the bottom edge of a wall sits against wet ground, it wicks continuously, and the interior finish is the first thing to report it. A downspout discharging right at the corner does the same thing faster. The cheap fix is dirt and downspout extensions. The expensive one is a rotted sill plate or rim joist, which is structure, and structure is a different order of expense. A useful tell that costs nothing. If the mark tracks with the irrigation schedule and ignores the rain, the sprinklers are the leak. 10th, and now the source is the ground itself, marks on a basement or foundation wall which arrive in 2 forms that get confused with each other constantly. A tide line is a horizontal band at a consistent height. It records a water level, which is a very specific piece of information. Water stood there, and the height corresponds to whatever drainage condition allowed it to. Efflorescence is a different animal. It's a white, chalky, sometimes crystalline bloom, mineral salt left behind after water moved through the concrete or block and evaporated on the inside face. It isn't mold, and it does no harm sitting there. It's also a receipt proving water is passing through the wall. They call for different responses. Efflorescence spread broadly across a wall face suggests capillary wicking through the whole assembly, which points at exterior drainage and grade. Efflorescence concentrated at one cracker joint suggests active seepage at that specific point, which is a far smaller job. A tide line paired with either one tells you how high the water got, and that number decides whether you're managing groundwater or chasing a single defect. Now the one that breaks the pattern. Sometimes a mark keeps coming back through every coat of stain-blocking primer. The moisture meter reads bone dry every single time. The weather log shows no correlation with anything, and every plumbing test comes back clean. When that happens, the honest answer is that it may not be water at all. The phenomenon has a name in the trades: ghosting or thermal tracking. Airborne particulate, soot from candles, cooking, a fireplace, ordinary household dust, deposits preferentially on the coolest surfaces in a room. Framing members conduct heat better than the insulated cavity between them, so drywall directly over a stud or joist runs a little colder than the drywall beside it. Particles stick to cold. Over a season or two, faint dark stripes appear that follow the framing exactly, at regular intervals, and they resemble water staining closely enough that people chase leaks for years. The diagnostic route is completely different. Geometry is the evidence. Perfectly regular spacing that maps the framing layout, sometimes with an outline around the ceiling perimeter or a rectangle where insulation is missing. It correlates with heating season, with candle or fireplace use, with cooking, and with houses that are shut up tight. And it responds to insulation, air sealing, and ventilation. No plumber or roofer can touch it, worth ruling in before anybody spends money opening a ceiling. Set the 10 side by side and something uncomfortable emerges. They look like 10 unrelated problems in 10 different rooms, and mechanically they're variations on the same 2 failures. The first is a path. Water almost never fails in the middle of anything. It fails at transitions, a joint, a penetration, a change of material, a change of plane, a change of temperature. The tub meeting the wall, the pipe through the plate, the window into the wall, the roof into the wall into the ground, the wall into the groundwater. Every one of those is a place where two systems meet and somebody had to decide how they would overlap, and that decision disappears from view the moment the finish goes on. Even the condensation entries fit, because a cold duct sitting in hot, humid air is a temperature transition doing exactly what a physical one does. The second failure is drying capacity, and this is the half that converts a wet event into a bill. Federal guidance on mold is unusually blunt about the timeline. Material dried within 24 to 48 hours will, in most cases, not grow mold. The water restoration industry's own standard runs the same clock from the other direction. Clean water from a sanitary source starts in the least contaminated category, but sitting against building materials for roughly 24 to 48 hours, it can degrade into the next category, and further from there. And once porous material has been wet long enough to grow mold, the guidance stops being about drying at all. Absorbent and porous materials, ceiling tile, carpet, cellulose, and fiberglass insulation are expected to be discarded and replaced because mold grows into the pore structure and can't be removed completely. That's the entire cost engine in one sentence. The same amount of water costs a few $100s where an assembly can dry and many thousands where it can't, and whether an assembly can dry was decided by whoever built it. Which brings up the counterintuitive thing about stains that stop changing. A growing mark is honest. It tells you water is still arriving at that exact spot. A mark that froze in place has two possible meanings. The leak stopped, or the water found a lower, easier exit and is now landing somewhere with no finished surface to stain. Inside a wall cavity, on top of a ceiling, in a bed of insulation. That's an inference rather than a rule, and plenty of stains stop because somebody actually fixed the roof. But it's why it stopped changing, so I primed it and painted it, is such a common opening line in the stories that end with a 5-figure invoice. So what actually changes the outcome is a rhythm, tied to season and to specific places. Late summer, when humidity peaks and the air conditioner runs hardest, is register and duct season. That's when condensation staining declares itself, and when a trip into the attic on a hot afternoon finds sweating metal well before anything reaches the ceiling. The first sustained storm with real wind is elevation season. Walk each side of the house during or right after it, note which way the wind came from, and check the interior corners on that side. Late fall, before the ground freezes, belongs to water management, where downspouts actually discharge, whether the grade still falls away from the wall, whether mulch or a new patio has quietly eaten the siding clearance. Winter belongs to the cold surface marks. Fastener dots, ghosting stripes, and attic frost all appear when the temperature difference across an assembly is at its largest. Twice a year, regardless of weather, pull the refrigerator, check under every sink, and run a fingernail along the caulk joint in every shower. Those three take 20 minutes combined and cover a startling share of the expensive failures. And every single time a mark changes, mark it. Pencil line, date, photograph. That's the cheapest instrument in the building, and it does something no professional can do after the fact. It establishes when a thing started. Given that insurance language draws its line at continuous seepage over weeks and months, and often names 14 days specifically, a dated pencil line around a stain is a document with money attached to it. There's a boundary worth naming too, because none of this is an argument for handling everything alone. Deciding which fixture, which elevation, which weather, whether the thing is still active, that's homeowner work, and it's the part professionals most often have to guess at anyway. Opening assemblies, replacing flashing, handling contaminated water, and anything involving standing water near electrical equipment is equipped work. Federal guidance draws its own practical line for mold at roughly 10 square feet. Under that, a homeowner cleanup is generally reasonable. Above that, or after significant water damage, it points toward the commercial remediation guidance and toward people with proper containment. The shift underneath all of this is small, and it changes everything. A mark on a ceiling is the only instrument a house has for telling you where water goes when it isn't supposed to go anywhere. Read it that way, and it answers 3 questions. Where did the water stop? Is it still coming? And can what it passed through dry out before the clock runs down? Answer those 3, and the can of primer comes out at the end of the job once the water path has been dealt with. A house doesn't really have a waterproofing problem. It has a water path and a drying rate, and both of those are things a person can operate. If you've been walking under one of these for a year and telling yourself it's cosmetic, the comment section is a genuinely useful place to describe it. Which room, which wall, and whether it has changed since you first noticed it. Putting a mark into words for somebody else forces you to answer the two questions that matter, and people are remarkably good at recognizing their own ceiling inside a stranger's description. Like it if you will never look at a brown ring the same way again. Subscribe if you would rather learn to read a house than keep repainting one.